All right, I hope you guys watched the first video I posted of the, I don't know if he was called the calculus tutor or something like that. I think you should go back and watch that first before you do these notes, because I like how he explained what the substitution rule is and why it works to do integral. So here's kind of what we're applying, but I'm going to kind of show you how to show work, and we're going to go through these example problems together. When you're done with going over these notes, I thought what you could do to save yourself some pictures and save me having to look at more than one picture is just like maybe put page 25 and 27 together like this and take a picture when you're done, and then flip it over and have like page 26 and 28, take a picture, and then I'll just know that you did your notes. So let's get started. All right, example 1. And sometimes you might be questioning, what should we set u equal to? It's kind of like a guess and check, but I'm going to set, let u equal x to the 4th plus 2. So then if we take the derivative of u in terms of x, because we have u and x, that's why you write it like this to get started. So again, we're not taking the integral right now, we're taking the derivative. So the derivative of x to the 4th is 4x to the 3rd plus 0, which you don't have to write that down. Or not 0, but just 4x to the 3rd. And then what you want to do is get this du by itself. So now we have du is equal to 4x to the 3rd times dx. So we're really close. We have this x to the 3rd and we have dx. That's good. This 4, we kind of don't want that in our problem, so you can just divide it on the other side or multiply both sides by 1/4, if that makes sense. This is all multiplications here. Let's do that. So 1/4 of du equals x to the 3rd times dx. So that's kind of the hint over here, is you want to get these in terms of something that you see in this problem. Okay, so what this is going to equal is we can replace this x to the 3rd and this dx with, I'm going to put the 1/4 out here, du. So see how that du kind of affected both of those, times cosine of u. Okay, now this is going to be easy to take the integral of. So the derivative of sine is cosine, so the integral of cosine is sine. And this 1/4 gets applied. And then remember, so this is sine u. And now your final step is to plug in what u equals. So our answer is 1/4 sine of x to the 4th plus 2. And then don't forget, on these integrals that don't have numbers that we're going to calculate, you want to write your plus c at the end. Okay, so now let's move on to example 2. So we're going to let u equal 2x plus 1. So the derivative of u in terms of x is just 2. The derivative of 2x plus 1 is just 2. But we are going to write this as du equals 2 times dx. But we don't have a 2. I know we have a 2 here with this 2x, but we don't have like an extra 2 anywhere. So really all I want to keep is this dx. So du divided by 2, or I like to write it 1/2 times du equals dx. So I kind of like to just do this algebra work over here and then go ahead and plug in what we know. So I'm going to write this as the integration of square root of u times dx. Okay, so all I did was kind of replace that. Now let's replace this dx with the 1/2 du. Well, I want to write the 1/2 out front, and then square root of u times du. So I've just substituted this in for dx, putting the du here and the half here. Now, if you want to think of u, square root of u, I'll say myself a line here, as u to the half. So let's think of what the integral is of u to the half. This is how I do it. We know we want this to become 1 unit bigger, so this will become a 3/2. But then we don't want, when you would do the integration of the derivative of this, the 3/2 would go in front. But we just want the number 1 here. So 3/2 times 2/3 would equal 1u to the 1/2 power. And then don't put this integration again. Like, this is applying the integration. So you don't want that integration symbol anymore. We want to bring down the 1/2. And then this, in terms of du, that just kind of turns into this. You don't want to write du again. When you take the integral of this, it just becomes this 2/3 u to the 3/2 power. Okay, so we can go ahead and multiply and we get 2/6, which reduces to 1/3 u to the 3/2. And now it's time to sub back in what u equals. So 1/3, move this up a little bit, times 2x plus 1 to the 3/2 power, and then remember to write the plus c at the end. All right, for example 3, we're gonna let u equal this 1 minus 4x squared. So the derivative of u in terms of x would be, the derivative of this would just be negative 8x. So if you look back, we have an x in this problem, but we don't have a negative 8. And then also we want to get du, or we want to get a dx over here with the x. So I'm going to do this in 2 steps. Negative 8x times dx. But then I don't want this negative 8, so to get rid of a negative 8, you multiply by negative 1/8. So this would leave us with x times dx. So again, you want to have this look similar to something you could substitute in here. So I'm going to do, and some of you guys might want to skip this step right here and you want to go ahead and plug this in. That's fine. I'm just going to show like one more step. So we plugged in u here. So now let's keep plugging in. So we can plug in x times dx in place for x and dx, but we need to plug in our negative 1/8 du. So again, we're going to write our negative 1/8 out front, and we're replacing this x times dx with du. So if this gets replaced, it's kind of like saying 1 over radical u times du. Does that make sense? Because this x was right there, and we're plugging in this quantity, negative 1/8. So think of what 1 divided by radical u really means. U to the negative 1/2 power. So now let's find the integration of this. So do not put your integration symbol anymore, because we're taking the integral of this. So if we would make this exponent 1 higher, it would become a positive 1/2. And I would need to put a 2 in front of this, right? Because 1/2 times 2 would be u to the negative 1/2 when you take the derivative. So remember, you can check. If you take the derivative of your answer, you should get back to where you started. And then I need to bring down this negative 1/8. So this is going to equal negative 1/4 u to the 1/2. And now sub back in what u equals. So negative 1/4, 1 minus 4x squared to the 1/2, or we could make that a square root. I think I like that better. And then your final answer, make sure you write that plus c. Okay, question 4, this one's gonna be a little faster. U is gonna equal 5x. Du over dx is going to be 5. So du is just going to be equal to 5 times dx. And I know there's a 5 up here, but remember, this is going to get replaced with a u. I really want to get dx by itself. So 1/5 times du equals 5. Okay, so let's rewrite this as e to the u dx. And now let's plug in, oh, no, you guys caught my mistake, I hope, right? This should just say dx. Okay, so we're replacing this dx with 1/5 du. We're going to write the 1/5 out front and then du. And the reason we do this is because you can take then an integral. Sorry, you guys couldn't see that. You can take an integral as long as you have the same variable, e to the u and d to the u. So if you guys remember, the integration of e to the x is just e to the x. So it just stays e to the u. That's the integration of that. And then we're going to sub back in. And we're going to put our 5x in for u, and then plus c. There's our final answer. Okay, this one was a pain. I had to try it multiple times before I got it. So I think what I'm going to do is I'm going to show you my work here and kind of just explain it. So in the very beginning, I let u equal this 1 plus x squared. Did all this work. Okay, and I highlighted that in pink. Now also what I did was I rewrote x to the 5th as x times x to the 4th. That's okay. So I just kind of rewrote this problem subbing in u x times x to the 4th. Unfortunately, though, we don't have anything right now to plug in for x to the 4th, but we kind of do. So if you take this equation right here and get x squared by itself, so we just take u minus 1, x to the 4th would be that squared. And remember, I have to do the FOIL method. So this orange right here can go in place of x to the 4th. So if you guys need to kind of like pause and like plug everything in. So here's my 1/2 du. I took the 1/2 out here and my du here. And now do you see we have a term with all u's. So here's where I kind of screwed up. I tried to integrate right at this point and I shouldn't have. You want to turn this all into one single trinomial. So rewrite this as u to the 1/2 times this trinomial and then distribute the u to the 1/2. And then you can take the integral of this. Okay, so what you would do is take the integration of this, and I went back to fractions because I thought it worked better. Then you have to multiply everything by 1/2, and then this is the final answer. This question's in your book too, so if you want to look back in your book, you can, but this one was definitely a pain to work out, but it's kind of like one of those things you do get smarter and better at it the more you work at it.